Let's look at some different ways that we can think about slope. So first, let's talk about visually what will happen with slope. When slope is positive, you're going to have a line that's increasing. Now, when we talk about increasing or decreasing, it's the idea of reading left to right. So starting at the furthest left point, having something low, and then going up to something high. This would have a positive slope. So for slope, we use the letter M to describe what the slope is. So in this case, when we calculate our slope, it's going to be a positive number of some sort. So it's increasing that the y value gets larger as we move to the right. For negative, it's the opposite. It would be a decreasing line. So it'd be moving downward if we were reading left to right. And with that, when we calculate our slope, we'd end up with a negative number. Now when the slope is 0, so if we go and calculate slope and we get a value of 0, this is going to give us a horizontal line. So something that would look like this. And for the equation of the line, so when we get to equation of the line, we typically fit this form of y equals mx plus b. And right now we're just focusing on what the value of m will be. When you have a slope of 0, the equation changes a little bit, and you can imagine if we took that slope of 0 and plugged it in, well then that 0 times x, that'll just disappear. So when you have a slope of 0, all you end up with is y equals, and then b, which is our y-intercept. So really you just end up with y equals a number, because the idea is for any x value, y is going to be the same number every single time. To have an undefined slope, so what will happen in our calculation is you'll be solving for m, and this is a case where you'll end up with some number in the numerator, and then you're dividing by 0, which can't happen. That's going to lead to having something that's undefined. So what this will look like visually is a vertical line. Now this is a case where we can have all sorts of different y values, but the idea is that the x value always stays the same wherever you're landing along the x-axis. So to have a line graphed that has an undefined slope, the equation for that line is just going to be x equals some number. So if you have an equation with just x equals, let's say it was positive 3, then that line would look like this, where you'd have positive 3 for every possible value of y. Whereas when the slope is 0, and say y is positive 3, then that means that x can be anything, but y is always positive 3. So that's the way you can get an idea of what the slope should be before calculation if you have a graph to look at. There are so many different ways to think about how to calculate slope, but what it comes down to is a numerator and a denominator. So the numerator is all about rise, moving up and down, which moving up and down is along the y-axis. So really we're thinking about, and what this triangle represents there means change. So we're thinking about how y changes, which can also work if you have two coordinates. Say we had some coordinate x1, y1 and x2, y2. For that numerator, if we're trying to see how y changes, what we do is we take the difference between those two y coordinates that we're trying to match up. So we take the y value from coordinate 2 minus the y value from coordinate 1. In terms of thinking about up versus down, when we're thinking of rise, up is going to be associated with a positive movement. So that would make for a positive change in y. If we need to move down, that's going to link to a negative value. So that would be a negative change in y. Run is how we move right and left, which is along the x-axis. So in the denominator, we're thinking about how x changes. or we could think about this difference between the two x coordinates. Moving to the right is going to be associated with a positive value, and moving left will be associated with a negative change in x. Now, when we use this formula at the end here, just be careful that the order is correct. So numerator should only be y coordinates, denominator should only be x coordinates, and then visually how I think of it is if you look vertically, those coordinates come from the same point. So in the numerator, your y coordinate, denominator x coordinate, that should come from a single point that you're graphing. And then same thing here, vertically, those points match up to coming from a single coordinate on your graph. Okay, so if we have a picture, how do we find the slope? So you want to find two coordinates, and typically you want to use two coordinates that are clearly on specific values. Like you wouldn't want to use something that's kind of in between because we can't tell exactly where that point is. But here we have two coordinates. We have, this would be 0, -3. And here we have the coordinate 3, 3. Now we can use this formula up here. We have the two coordinates and you can plug in and solve, but let's talk about visually seeing our rise and run. So what I want to imagine is, I always think of like a little bug, being a bug starting at this point, and then this bug can only move up, down, left, or right. And basically I want this bug to move so that it can get to that other point. So what I just mapped there is I'm going to have this movement of, I need to go up to get to that second point. I'm going to stop there because then I'll move to the right. So that movement up, that's going to be the rise, and then I just need to calculate how far did it rise. We went 1, 2, 3, 4, 5, 6 units. So it's going to be positive since that movement was upwards. And then we moved to the right, which is also a positive movement, and then we moved to the right 3 units. So in terms of rise over run, the rise is up 6. So I'd have that positive 6 in the numerator, and then the denominator of the run was a positive 3. And then I would just need to simplify, so this is all going to be positive, and 6 divided by 3 is 2. So give me my slope. With this one right here, same idea. It doesn't matter which spot you start at. I could start here and then figure out how to get to the second point, or I could start at the second point and go back. It'll be the same thing. I usually think of reading left to right, so I'm going to start with this left-hand point. So my first step, there's a few ways to see this. How about, let's go down first. So I'm going to go down 3 units. So since we're moving downward, that's going to be negative, and then distance of 3. And then I need to move to the right, so this will be positive. And then I just need to count 1, 2, 3, 4, 5, 6, 7, 8, 8. So for my slope, I have my numerator, denominator. So rise is the -3, run is the positive 8. And there's nothing to simplify with the fraction, but overall I'll have a negative number, so negative divided by positive makes a negative, and then that'll be 3/8. So that's how you can see rise over run visually if you have the graph. So let's talk about having two coordinates and calculating slope. So when you have two coordinates, you just want to figure out which is x1, y1, which is x2, y2. It doesn't matter. You can go in any order. So I'm just going to call this first one x1, y1, and this will be x2, y2. If you switch it, once you simplify, you'd get the same exact number as I get right here. Okay, so It's this point where we just need to be really careful with how we substitute. So in the numerator, I want this difference of y values. I want to take y2 minus y1. So y2 is a negative 13. And then based on the formula, we'll always have subtraction. And what I just need to make note of is I'm subtracting, so y1 is a negative 20. So since I'm subtracting a negative, you can either change it to addition at this point, or if you just want to see that substitution, using parentheses always helps. So this way I can see my y2 of negative 13 minus y1 of negative 20. And then I'm going to do the same thing for the x values. Now, like I was saying before, make sure it lines up that those two values come from the same point. So negative 13 goes with negative 20. So I'm going to plug in my negative 20 from that x2 value minus, and then it's a positive 16. And then we just start simplifying. So in the numerator, I'll have negative 13 plus 20. In the denominator, negative 20 minus 16, which is negative 36. And then negative 13 plus 20, same thing as 20 minus 13, so that's going to be 7 over negative 36. And then we just want to make sure that our fraction is completely simplified, which that is. If you're unsure, you can plug it into that Desmo Scientific Calculator, and I'll show you a reduced form. Now notice that I have the negative down here in the negative 36. You can write this fraction like I did, 7 over negative 36, or you could even write it as negative 7 over 36, or you can write it as negative 7/36. Those are all the same values. Typically when we get to graphing, like given a slope and needing to make a graph, you'll want one of these first two forms so you can see how is the rise and run moving versus up, down, left, right. But in a simplified form, you can have the negative out front, and it's all exactly the same. Okay, one more example here. So we just need that this is x1, y1, x2, y2. So y2 is 13, and then minus y1, which is positive 11, divided by x2 of 3, minus, and then x1 of negative 12. And once we get the routine of just plugging in, again, I just do a quick double check that I do have a coordinate 313. I do have a coordinate that's negative 12, positive 11. So those line up correctly. Everything's plugged in right. In the numerator, 13 minus 11 will leave us with a 2 over, and in the denominator, the double negative will turn into addition. So this will be 2/15. All right, so that's how we can find slope, either given two coordinates or given the graph in tracking rise over run.